So let's do something a little bit more real world with Flume here. What we're going to do next is set up a Flume flow where we have a source that's just listening to a directory, listening for files that get dropped into it. That's called a spool-dir source. It will then transfer that again through a memory channel to a HDFS sync. So what we're going to do is have Flume monitor a directory for new files that get dropped into it, and then put those into HDFS in a certain file structure. And we're going to do that in kind of a fun way, so let's dive in. I still have two windows open up from the previous lecture, both connected to my sandbox from Hortonworks, so let's get a more interesting configuration file. I am, again, in the home directory of MariaDev here, and let's do wget media.sundog-soft.com/hadoop/flumelogs.conf. And let's take a look at what's going on in here. Less flumelogs.conf. Bigger file this time. It's got more going on, but let's walk through it. So again, we start off by defining our source, our sink, and our channel name. So we're going to have a A1 agent that we're using for everything in here. And it will connect to an R1 source, K1 sink, and C1 channel. These are arbitrary names that you just have to use consistently. For our source, we're going to set it up as a spool-dir, like I said. And spool-dir has a few different parameters you can set on it. So we have to set not only the type, but also the directory that it's going to listen to. So we're going to create a spool directory under our home directory where this source is just going to monitor, and as new files get dropped into it, it will consume them, push them into Flume, and then mark them as completed. We're also going to say that we want to include a file header on these files as they're pushed through Flume. Flume, that's an interesting word. And we're going to attach an interceptor to it, a timestamp interceptor in particular. So this will actually append information to each event saying at what time, what date, what time it was actually generated. So as files get dropped in, they'll get timestamped, and that time information will flow through to the sink through the channel. So not only are we sending through the file itself, the data in the file itself, we will also send through the timestamp of when that file was dropped in. Okay? So just to repeat again, what this is going to do is monitor a directory, the spool directory in my home directory for new files. If a new file is found, it will go through every line and make a new event out of each line, timestamp it, send it through the channel to our sink. And our sink is an HDFS sink. And check out what's going on here. So we're using some escape characters here. We're going to say we're going to put it into the Flume directory under user MariaDev on HDFS. Okay, this is no longer the local file system. This is potentially stored on a cluster using this date format, %y, %m, %d, %h, %m, /%s. So this is kind of interesting. We're saying that we're going to create new subdirectories for each unique date and each unique hour-minute combination. And furthermore, we are going to round all the minutes down to 10-minute intervals. That's what these last three entries mean here. Okay, so what ends up happening is that we get new subdirectories being generated for each 10-minute interval that goes by. So if I drop in, a new file at 10 a.m. on today, then it will go under a folder for today's date, and then under there we'll see a 10.00 folder for things that came in between 10 o'clock and 10:10. And the files will be stored under there with a file prefix of events dash whatever the actual second was for that. So because it had that timestamp interceptor, that time information from the header can be extracted and automatically placed into that file path in that manner. So that's something special about the HDFS sync. It can actually see these special magic characters with percent signs and parse out timestamp information if it's present. Okay, so that's what's going on there. Finally, we just need to do what we did before and assign both of them to a memory channel. We will set up the channel itself and then assign both the source and the sink to that channel. So this connects all the dots together, if you will. So again, to review, this configuration file is setting up a spool-dir source that listens for new files in a given directory on my local file system, pushes them through a memory channel into an HDFS sink that will then store that data in HDFS in a directory structure that keeps track of the time that was stamped onto that source data. So let's actually see it in action, because this is a little bit more interesting, isn't it? So first we need to create the directories that we're going to be using. So remember we said we were going to pull the spool directory for new files, so we need to create that directory first. It does not exist yet, so let's say mkdir spool, and that will be the home that we're going to drop our files into that we'll be monitoring. And we also need to set up our file, our folder on HDFS that things are going to go into. So let's bring up Ambari. Log in as admin, why not? And go to the Files view. And our configuration file said it was going to store everything under user, Maria dev, and from there it was Flume, wasn't it? So new folder, Flume, add. All right, so we're ready to rock and roll. So over here, let's start our Flume server again. And this time, we're just going to run the same command that we did in the previous example, but just use a different configuration file. So instead of example.conf, I'm going to change that to, what was it called? flumelogs.conf. Everything else is the same. We're running the Flume ng to create a new agent with the conf configuration folder for Flume itself, using the configuration file flumelogs.conf in my home directory. The agent name is still A1. We didn't change that, and we're going to keep on logging stuff. Why not? So let's go ahead and kick that off. Bang. A little bit more of a complicated example, so it's going to take a little bit longer to spin up. And there it goes. Let's go ahead and it's monitoring the spool directory and starting and stopping all these monitors that are running on it. So let's put some data in there and see what happens. We still have the access log small text file from the Kafka exercise that we did earlier. So let's copy that into our spool directory. Copy access log small.txt into spool / and let's call it something arbitrary, fred.txt. In the real world, it would be like access log and some number, right? But all right, and over here we should see something happen. Looks like a little bit of a change. There we go. It's doing something. That's cool. So let's see what's going on. Let's see what happens. So let's go into the spool directory and see what's in there now. And you can see that it stuck automatically a .completed suffix to the file, and that indicates that Flume has consumed that data and done what it needs to do with it. So it's safe for you to get rid of it now if you want to. Let's take a look in HDFS and see what's in there. So go back to Ambari and the files view. Let's go into our Flume directory. Sure enough, there is a date, just like we specified. So it created a folder for today's date. Happens to be, well, you know when this video was made now, don't you? It's Valentine's Day in 2017. And from there, we are in the 2200 hour military time, the 40-minute block. And indeed, it's 5:44 p.m. right now. And inside there, it's stored inside the 00 subdirectory, all these event files. And this is the actual data that was published. One line at a time from those logs. Let's take a peek at one of them. And by default, it's in sequence file format. So we could have specified text format if we wanted to be able to more easily read it, but these sequence files are appropriate for loading straight into Hive or Pig or a bunch of other stuff, right? So we have set up a Flume flow here that has taken raw log data and imported them into HDFS in a file structure that helps us keep track of what came in when, and in such a format that it's easily imported and analyzed by other tools on our cluster. So I hope that sinks in kind of the power of what we're doing here. It's pretty cool stuff. That's Flume. So that's closer to a real world example. Let's go ahead and Control C out of the agent here. And at this point, we're done with Flume. We can exit out of these two terminals and shut things down if we so desire. Cool. Okay, we've covered some ways of actually publishing data from your web servers or sensors or wherever your data might be coming from in real time into your cluster for processing. So up next, let's talk about how we actually process that data once it comes in.